This is a video on how to use it. The shortest path node is resolved in Blender sverchok. A geometry that specifies the starting and ending points to get a shortest path problem. This node is a script node created that relies on the sverchok script node. First add the script in the text editor, and then add the shortest path node in the script node. I've put this shortest path node on Blender Market for you to support and download. And I'm going to take this. Sample files are also packaged with the corresponding product. I'm going to go through these two simple little examples here. How can this node be used? So the first thing we're going to do is get a random structure like this. Use these two nodes. You can see that you've got one. This is the geometry. At this point we input the point data and the edge data of the structure into the hole. A node. Because we chose one shortest path edge, so here we go to edge mode. We also use list input nodes to specify the start and end points and enter them into the start and end slots. In this case, our node will print one point index to the edge of the nearest path. The output is point index data. At this point we need to put the point index is converted to a point mask for the corresponding model data. Generates a mask for the shortest path point through this node, and then masks this point. Converts to an edge mask. And then go through this mask to get it right. Make a selection of the entire edge data. This will output a corresponding shortest path edge data. We can modify this parameter to see the system. The model object will always find the shortest path. Now this is the second example. To specify the starting and ending points in a plane. Look for one of these faces. Shortest path. In this case, we're going to choose face and then we can switch between the two modes. In this mode, selecting a face takes into account its diagonal face. We're going to ignore the diagonal faces when we switch. You can switch according to your own needs. Here we need to input the point, line, and surface data of the model into the corresponding slot. And decide on a starting diagonal and an ending point. This requires a midpoint on the input plane. This is the time we need. The element analysis node in the parser. It will output the midpoint of a face based on the input and then output that data to this node. The following barrier block requires the index of the input surface. Here we use random number nodes to enter some random numbers that are not repeated. We can go and increase the number. Blocks are actually things on this surface that you can't pass through. An index of the face. The last one is the weight of the fastest algorithm, and the closer it gets to 1, the faster it gets. But sometimes you don't get a shortest path. When there are some errors, can be appropriate to reduce the value. When this number is 0, 5, the node must be able to find the shortest path, if one exists. This can solve some problems like mazes. Find the best route. This time the output is the index of the face. In this case we can use this index selects data for output. Get the corresponding surface data. When we have multiple beginnings or ends, we can use lists are added to merge multiple starting and ending points. At this point we are exporting two pieces of data. So here we need to have this data is untangled. In hierarchy 2 mode, two pieces of data are merged into one. And you can see here. So multiple starts or ends. It can also search for a shortest path. Believe through these two simple little examples, you can get a simple idea of what this path node is.